Step into a world where technology and agriculture unite to create a landscape of endless possibilities. In this video, we unveil a remarkable assortment of machines and tools that are propelling the farming industry into a new era of efficiency and sustainability. Witness the precision and expertise of autonomous fruit tree pruning robots. Explore the water-saving capabilities of precision sprinkler irrigation systems. Discover the transformative power of livestock health monitoring sensors in ensuring animal welfare. Experience the efficiency and accuracy of GPS-guided potato harvesters. And marvel at the advanced crop storage solutions that extend shelf life and preserve quality. Together, they represent a paradigm shift in agriculture, where precision, automation, and innovation intertwine. Number 5. Autonomous fruit tree pruning robot. A robotic system that is meant to automate the process of trimming fruit trees is referred to as an autonomous fruit tree pruning robot in this context. These robots make precise cuts and use advanced technology and algorithms to locate branches that need to be pruned. This allows them to improve the pruning process for increased productivity. Robots that are capable of autonomously trimming fruit trees typically consist of a robotic arm or manipulator that is outfitted with various pruning equipment, such as pruning shears or saws. It is possible to prune the tree and reach different portions of it with the help of a robotic arm that has been engineered to move in a manner that is analogous to that of a human arborist. These robots have vision and sensing systems built into them, which allow them to properly detect the branches that need to be pruned. In order to examine the structure of the tree and the branch growth patterns, as well as locate diseased or damaged branches that need to be removed, machine vision technologies, cameras, and sensors may be utilized. Artificial intelligence, AI, algorithms are utilized by autonomous fruit tree pruning robots in order to conduct data analysis, as well as make pruning judgments based on the information obtained. These algorithms are able to determine which branches should be pruned based on predetermined criteria, such as the branch's angle, length, growth rate, or other health indicators. The robots are able to independently navigate through forests or groves in order to get to individual trees. They are able to map the area and navigate without the assistance of a human by utilizing localization technologies such as GPS, LiDAR, and others. Because of this, they are able to move quickly between the trees and complete the pruning chores with only minimum instruction from a human. Number 4. Precision sprinkler irrigation system. A precision sprinkler irrigation system refers to an advanced irrigation method that utilizes sprinklers to distribute water to crops with high precision and efficiency. These systems are designed to optimize water distribution, minimize water waste, and improve crop health and output. Precision sprinkler irrigation systems can use several types of sprinklers, such as impact sprinklers, rotational sprinklers, or micro sprinklers. These sprinklers are designed to deliver the water in a controlled manner, providing uniform coverage across the field. Precision sprinkler irrigation systems are developed to produce excellent water distribution consistency. This means that the system is designed to provide water uniformly to all sections of the field, reducing over or under irrigation and ensuring that each plant receives an acceptable amount of water. These devices allow for exact control over the amount of water applied to the crops. Through adjustable nozzles, pressure regulators, and flow control devices, the irrigation system can be adjusted to match the precise water requirements of different crops, growth phases, or soil types. Precision sprinkler irrigation systems generally integrate modern control systems, including timers, sensors, and weather-based controllers. These systems can automatically modify irrigation schedules depending on real-time meteorological data, soil moisture levels, or crop water requirements, optimizing water consumption and reducing water waste. Number 3. Livestock health monitoring sensors. The term livestock health monitoring sensors refers to a group of tracking and monitoring devices that were developed specifically for use with livestock animals. These sensors make use of a number of different technologies in order to collect data on a variety of characteristics, including rumination behavior, body temperature, activity level, heart rate, and other vital indications. Sensors for monitoring the health of livestock frequently take the form of equipment that can be worn by the animal, such as ear tags, collars, leg bands, or implants. These sensors are fastened to the animal in order to collect data in real time on the physiological parameters of the subject. Sensors used for monitoring the health of livestock are able to measure a wide variety of biometric data, including the animal's activity level, heart rate, breathing rate, and body temperature. In order to gather and communicate this information, these sensors make use of various technologies, such as accelerometers, thermometers, and heart rate monitors. Wireless technologies are often utilized by livestock health monitoring sensors in order to facilitate data transmission from the sensors to a centralized data gathering system. This may be accomplished through the use of Bluetooth, Wi-Fi, RFID, or cellular networks, which enables monitoring and analysis in real time. Farmers and other animal caretakers are able to remotely monitor their livestock's activity and health with the help of monitoring devices for livestock health. The information that is gathered from the sensors may be accessed via a computer, a smartphone, or a monitoring device that is specifically designed for that purpose. This allows for insights into the health of the animals to be gained from a distance. Number 2. GPS-guided potato harvester. Potatoes can be harvested in a way that is both efficient and accurate with the use of a specialized agricultural machine called a GPS-guided potato harvester. These harvesters make use of GPS technology, which stands for Global Positioning System, in order to navigate the field and make the harvesting process more efficient. Potato harvesters that are guided by GPS are outfitted with a Global Positioning System, GPS, navigation technology that offers precise positioning information. The harvester is equipped with a GPS system that enables it to precisely explore the field. This helps to ensure that the machine harvests all of the area and adheres to the established harvesting routes. There are some potato harvesters that are guided by GPS that also have yield monitoring systems built in. These devices measure the weight of the potatoes that have been harvested in real time by utilizing sensors or load cells. The information that was gathered can be put to use to monitor the harvest yield and productivity, which provides vital insights for the management and planning of crop production. Potato harvesters that are directed by GPS typically come equipped with auto-steering technology. The harvester's capability to autonomously modify its path and maintain accurate row alignment is made possible by the integration of GPS data with hydraulic steering devices. This function helps to reduce harm to the crop and enhance the efficiency with which it is harvested. Number 1. Advanced Crop Storage Solutions. The term Advanced Crop Storage Solutions refers to cutting-edge technologies and storage methods that have been developed to enhance the capacity for storing and maintaining harvested crops. These methods intend to lengthen the amount of time that crops can be stored after harvest, while also preserving their quality and reducing the amount of money lost after harvest. The natural ripening and aging processes of crops can be slowed down by using a technique known as controlled atmosphere storage, which includes changing the atmospheric composition within storage facilities. The quality of the crop can be maintained while minimizing losses due to spoilage if the storage environment is improved by making adjustments to the temperature, humidity, and gas levels, such as oxygen, carbon dioxide, and ethylene. The packaging of perishable goods in a changed atmosphere is a method that involves the modification of the materials used in the packaging in order to generate a certain gas composition around the goods being packaged. This helps to prevent the growth of microorganisms, keep the crop's freshness, and increase the amount of time they can be stored. MAP is typically utilized for delicate goods such as fruits, vegetables, and other foods. It is imperative to have access to cold storage facilities such as walk-in coolers and refrigerated warehouses in order to keep many types of crops at their peak levels of freshness and quality. Because physiological activities such as respiration and enzymatic activity are slowed down by cold temperatures, the shelf life of the crops can be extended as a result. Controlling the humidity within these storage facilities is also extremely important in order to stop the loss of moisture or the accumulation of excess moisture, both of which can cause food to go bad. Certain types of produce, particularly leafy greens and other delicate vegetables, can benefit from the rapid cooling that vacuum cooling provides. The procedure entails placing the harvested crops in a vacuum chamber and rapidly reducing the air pressure. This causes the water that is contained within the crops to evaporate, which in turn results in the crops being cooled off more quickly. The crispness, texture, and nutritional content of the crops are more likely to be maintained with the use of vacuum cooling.